Hello and welcome once again to Slooh Space Camera for another live astronomy event. We have got a fantastic show for you lined up tonight. We are going to be looking at a near-Earth object, an asteroid. Thankfully this one doesn't have our name on it, but we're going to be telling you all about asteroids from the ground up, exactly what they are, the kind of threat they may pose to us on Earth. But first of all, by the way, we've got a special guest tonight. We've got Mr. Bob Berman's going to be joining us in a few minutes' time. But I just wanted to start off by telling you where our live images are coming from tonight. The live images are coming from Slooh's observatory in the Canary Islands, which is off the west coast of Africa. This is a high-altitude observatory site, some of the biggest and best European telescopes based there, and that's where Slooh have got our telescopes. We've got a half-meter telescope there and a couple of small ones as well, and we are going to be watching live images from those telescopes tonight. Now, tonight the conditions are fairly challenging at the site. That we've got a full moon up tonight, we've got a lot of haze up, and we are looking at a very, well, it's a large object, but it's a long way away. So thankfully it's a long way away. But anyway, listen, the observatory, as I say, is off the west coast of Africa. And it's actually on top of this volcano. And it's well above the atmosphere, which is why the skies are usually crystal clear. You know, it's, we don't usually suffer. But anybody can use these telescopes. So amazingly, you can sit on your sofa at home, and it doesn't matter where you are in the world, and you can operate those telescopes kind of live. And there's a couple of ways of doing that. You can either join Slooh, become a member, or you can download the Slooh iPad app. We are going to be developing it for other applications as well, but that's the app at the moment. It's free to download, and you can just click with one button press on Saturn or the Andromeda Galaxy, and you will command those telescopes in the Canary Islands, and it will feed back a live image or an image that has been taken just for you straight back into the app. It's a really, really cool thing. So if you've got an iPad, I recommend downloading the Slooh iPad app. But listen, and help tonight, the fountain of all knowledge, all astronomical knowledge. I always call Bob Berman astronomy author extraordinaire, and that's exactly what he is. His most recent book, The Sun's Heartbeat, is a fabulous read if you're interested in astronomy, the sun, the solar system, all these kind of things. So hello, Bob. Thank you very much for joining us again tonight.
Oh, it's a pleasure, Paul, and thanks for that very generous introduction. It's very exciting being here as yet another asteroid zooms past. You know, I'm still trying to recover from that show that we did on February 15th when the closest one in years skimmed by between us and the moon, just barely missed us, and on that very day, another asteroid chunk comes in and explodes over Siberia. We all remember that just from a few months ago.
We'll talk, Bob, about the risks of these things actually hitting a little bit later on in the show, but we promised people tonight that what we were going to do was going to kind of give them a ground-up schooling in what a near-Earth object is. So we hear these terms bandied around. We hear near-Earth object and we hear asteroid and comet. What are these objects, and why do we have to get worried about them?
Well, as we will now look at, or very shortly look at live images of this extremely faint object that's just whizzing past Earth at the moment, of course, the reason we have to be worried is that's why the dinosaurs aren't here. That's why Earth has changed from time to time. We've been clobbered. It's not just Siberia. This past February, Siberia was struck, as we all know, by an exploding air-bursting meteor on June 30th, 1908, and it's changed the entire biosphere of Earth over and over again.
Several times,
Several times. So regarding them, it could be a comet. A comet is a small chunk of mostly ices. An asteroid is much more substantial. Asteroids were first discovered on the, I don't even know if you know this, Paul, on the first day, the opening day of the 19th century. First day of the 19th century, the first asteroid was found, and at first we thought that there were pretty women on them, as we just saw, an image of one. We thought that maybe they were populated, that they were planets that orbiting near us, but then we found more and more of them with names like Juno and Vesta and Ceres and Pallas, and eventually we came to see there are thousands of them.
So,
Chunks that range from 600 miles across down to just small little pieces of debris that
so
fly through our.
where do these asteroids hang out, Bob? And why aren't we always bombarded with them kind of every night? Why do these things seem to come up every few months and whiz by us? Is there a big population of these asteroids out there somewhere?
Yes. The main population is safely between Mars and Jupiter, but thanks to collisions between them and perturbations from Jupiter itself, some of them are knocked inward, and so we have several, actually many, that cross are little chunks of asteroids. Some of them are debris from comets, and most of them are chunks of asteroids that are only the size of apple seeds and that are harmless. But every once in a while, we'll get a larger one, and if it's only the size of, let's say, a baseball, okay, still no harm. What we're doing is fearing the larger ones now. This one that's passing us tonight is about 200 feet across. Now, that's the size of a city block.
Yeah, this is a sizable chunk of rock, and it's not just the size which makes them so threatening, isn't it? You talked about it whizzing by Earth. I mean, the kind of speeds that these objects are going at is the thing that generates the energy, isn't it, when they hit an atmosphere?
And this one, relative to Earth, is going 16 miles a second or so. Now, a fast, high-velocity rifle bullet goes 1/2 mile per second. So this is over 30 times faster than a high-velocity rifle bullet. And the explosive force, what physicists call the kinetic energy, is always equal to the weight times the velocity squared. So you take the velocity, and if we're studying two rocks and they're both the same size, but one is going twice as fast as the other, its damage is not going to be twice as much. It's going to be 2 times 2 or 4 times more. This one that we're tracking right now live, we're seeing it right in front of us, thanks to Slooh, is going 64,000 miles per hour. It's just about the same speed Earth moves. And that gives us a clue as to, by the way, where it's located. I know we're looking sort of in the direction of Andromeda, roughly towards the Andromeda galaxy. That gives us a clue because that's not the straight ahead direction that Earth is traveling right now, tonight. If it were, then it may be a head-on collision. Nor are we looking in the rear view mirror. We're not looking in the backward direction. Since this is traveling at about Earth's speed, this automatically tells us it is neither coming toward us nor away from us, but rather sideways relative to us. And therefore it's approaching us at about the same speed that we ourselves have, and that's pretty fast.
Now, I'd just like to point out to people tonight, you're looking at these live images. Now, this particular near-Earth asteroid is a pretty difficult one to spot, and the sky conditions really aren't helping us tonight. We've got this full moon, we've got really thick haze, and this object is really the faintest asteroid that we've tried to track at Slooh. So what we're looking for in these live images is a very small white line. Be looking for in these live images.
Well, I trust you to do it, Paul, if anybody can, because I know in all of our previous Slooh shows that have been tracking asteroids that have come very, very close, and we've had many people joining us to watch them, you have managed what seemed to me almost the impossible. When nobody else was doing it, you were tracking these close objects. But this one, boy, good luck. We're saying it's very close to us, but it's actually 11 times farther than the moon is. And being a city block, just picture this, something the size of a city block, but 11 times farther than the moon. Well, the windup is it's shining at 20th magnitude, which happens to be 250 times fainter than the planet Pluto. I'll say it again, 250 times fainter than Pluto on a night when the moon is nearly full.
Yeah.
So good luck.
This is a difficult one. So everybody out there, please keep a really close eye. And I know that Slooh members have already scheduled a couple more missions. We call an imaging session using the Slooh telescopes a mission. And I know that Slooh members are looking at not only this asteroid a little bit later on as well, but also a couple of others, a couple of really interesting ones, because anybody can use these telescopes that we're using tonight for this show. You can use them by joining up to a Slooh subscription. You can do that on a quarterly basis, and you can use these fantastic telescopes that we've got up there. We've got the half-meter telescope. It's got a brand new telescope mount. It is an amazing telescope, I'll tell you, and it's at this fantastic site, and you can control it from the comfort of your armchair. We've also got other telescopes that are really suitable for looking at the planets and smaller objects, and in fact, that's one of the ones that we're using to look at this near-Earth asteroid tonight. But don't forget, you can also control those same telescopes using the Slooh iPad app. It's really, really easy to use, and I'll tell you, it's got some fantastic features in it. One of my favorite things, I just want to tell you this before we move on with our near-Earth asteroid show. One of my favorite things, and today is a fantastic time to start, is collecting moon phases. So you can do every couple of days, you order up to control the telescope to take an image of the moon for you, and in the app you get to flick through all of your moon images, and you kind of see the lunar phase changing. It's really amazing to look at. But anyway, you can control these same telescopes that we're using tonight, and I'll tell you, it's a great deal of fun, and Slooh members, there's a fantastic community out there. Don't be worried if you think you're be a bit lost in the subject of astronomy. Don't worry, because we've all started in exactly the same place, and the Slooh community is incredibly supportive. Now, Bob, I just want to go back to basics once more, because we've said where these things are, but I was reading something the other day that there are kind of two main types of asteroids. You've got kind of rocky ones, but you've also got these iron ones. Is that right? There are two kind of groups of asteroid types. Do we know why they're split down into two different types like that?
Well, they started with the birth of the solar system, and originally the solar system was made up of chunks of material that were condensing out of the solar nebula, and in our neck of the woods here at Earth, and where Venus is, where Mars is, enough chunks were able to come together by self-gravity to eventually form whole planets. But between Mars and Jupiter, there was just too much meddling from Jupiter's awesome gravity, and so this instead kept them as chunks. But nonetheless, they were differentiated enough in their positions so that different materials showed themselves up, and they do when they collide with Earth. You know, when we find a meteorite, when a meteor survives its trip through the atmosphere and then lands, and then its name changed from a meteor to a meteorite, we notice that some are carbonaceous chondrites, and those are the rockier ones, and some of those, like the octahedrites, are nickel iron, and these are heavy and metallic, and they'll pull on a magnet, and so we do have the different types, and we're looking now in space. This is a live view looking at this extreme faint object. You know, those who have joined us before know that we've created animations, we've seen the streaks, we've seen the asteroid
let's take a look
as it whizzed past. So let's look at a recent one, asteroid Tutatis, as it went by about half a year ago.
Wow,
and what that looks like,
one, wasn't it, Bob?
Yes, yes. But these are actual Slooh images as this asteroid whizzed past about half a year ago. And the reason that Paul is showing this to you is looking at this brighter, larger asteroid will give us a little clues as to what to squint and look for tonight when we have a much fainter, further, smaller, full moon asteroid that's more of a challenge for us. But nonetheless, it's out there. We're looking for it.
Well, Bob, you say it's out there. I've got a couple of interesting little facts here that I was looking up. Now, there's a website that we use to look at the latest discoveries of near-Earth objects. And don't forget, near-Earth objects comprise comets. So near-Earth asteroids have two types of objects, and then there are other kind of smaller subclasses. But tonight, it's not just one that's making a close pass to Earth. There are four. I don't think we've on a night four near-Earth asteroids have made their closest approach to Earth in one night. But I've got some fascinating, what I think, fascinating facts here, because I want to move on to talk about the kind of risks funding to actually track down the tens of thousands of these objects that are estimated to be out there.
And that have not been discovered yet.
Exactly. And they've had their funding absolutely slashed. And I must say, I really support some of the NASA guys who were in one of these, I think it was one of your congressional hearings or something like this, and they were really defending themselves, like saying, look, you've got two options. If you don't want to give us the money, then we can't guarantee that something's not going to happen next week. But Bob, I want to tell you about the list of newly discovered ones. Now, of the next 50 known close approaches that are coming up over the next couple of months, so we know that there's going to be about 50 of these things making close approaches. 18 of them, that's 36% of them, were only discovered in the last 7 months. So there's 50 closest approaches coming up in the next couple of months, and 18 of them were discovered in the last couple of months. And this one that we're watching tonight, when was
4
this
days
discovered?
ago, right? Just like
exactly.
4 days ago.
So this is really, I think, where we have to start taking this risk really, really seriously, because here are objects which could, you'll tell us, I hope in a minute, the kind of damage that these things could do. And you know, in the old days I used to tell people, hey, look at the moon if you want to see if these things impact, or take a look at the Barringer crater, meteor crater in Arizona, if you want to see the outcome of one of these things hitting. But we don't need to do anything like that anymore, because a few months ago we all saw one of these things burning up in the skies above Russia. So we all know that these things come into Earth's atmosphere and they also hit the ground if they're big enough and their trajectories right. So these things are only being discovered literally days before they make their closest approach. Now, some of you out there might be thinking, closest approach, well, these guys have said it's further out than the moon. But look, I was looking at the diagram tonight. We've got 4 of these things making their closest approaches tonight. I was looking at one of the orbit diagrams tonight, Bob, and I was thinking, that just looks like a bowling alley to me. It looks like a shooting range with little Earths kind of sitting there, orbiting the sun, with these things flying in, basically, to the inner solar system.
Let's look at, here's
from
the
all
current
directions.
position. Yes, here's the current position of the planets relative to Earth, and here is this asteroid. And look at it. Look how it's meeting us, meeting our orbit, and then scooting back into space. Here's the look at how the planets relative to Earth are situated, and here this comes, and wham! There is that near collision at this point. So,
and Bob, I think it's important for us to say here very clearly that we're not scaremongering. We're not interested in that. We're interested in educating people out there. And what I always say to people is, this stuff doesn't need sensationalizing, because it's sensational enough. You know, these things are being discovered a few days before they make the closest approach. This particular one definitely isn't going to hit Earth, and actually it's not even classified as a potentially hazardous asteroid, but one of them tonight is. And can you explain what a potentially hazardous asteroid is, Bob?
Well, that's any asteroid whose orbit or potential orbit, especially after Earth has maybe wiggled it a little bit, as we will with Tutatis coming up into the potentially hazardous. And unfortunately, we don't know about all of them. The majority are now thought, especially what we've seen in this last year, are now thought not to be known and we find them only when it's too late. Even if we had the capability, by the way, of shooting them down, uh, they're coming in too fast for us to
Yeah.
see. So it's very interesting, and all we have to do is look at the craters on Earth, the craters on the Moon, and the
Yeah.
changes on Earth. Do you know that there is a? I know you know this, Paul. That there is a worldwide dust layer that wherever you go on the Earth, if you dig down to
Yeah.
where the Earth was exposed to the ground 65 million years ago, at the boundary between the Cretaceous and Tertiary periods, there is iridium and osmium in an enriched form, showing that something big hit us at that time and rained down as dust all over the Earth, destroyed
Worldwide. Yeah.
worldwide. And we found the crater. It's located off the coast of Mexico, the Chicxulub
Yeah.
crater. We know it destroyed the dinosaurs. And so these things have changed Earth in the past.
You know, Bob, one of the other ones that are making a close pass tonight, not as big as the one that we're tracking live tonight, but one of the things that intrigued me about this other one that was discovered, literally just 6 months ago, this one was discovered. It's got a very small, close orbit. It makes a close pass to Earth twice a year. But this thing was only discovered 6 months ago. So this thing, for the last probably hundreds of years, has been coming, within a very close range to Earth twice a year. But it's
Yes, let
only
me point
six
out
months ago.
that the image we just showed, it said
Yes.
asteroid Apophis. That was not Apophis. We were showing Gaspra and Ida and Gaspra,
Oh, well spotted.
two asteroids that have been visited by spacecraft. Just want to correct that so nobody
Yeah.
thinks we're in error there.
So
But I
Bob,
know, and I know we're looking at the live view now, aren't we?
we are. We are. Now, Bob, go back to our show earlier on in the year, because we were covering the close pass of quite a sizable rock at that time, I think. And wasn't it the following morning or no, it was the morning before, wasn't it? We all woke up to the news in Russia, and we saw this thing kind of streaking across the sky and burning up with this huge release of energy. What are the kind of threats? How big do these things have to be? What kind of trajectory do they have to have before they can do what kind of damage to the Earth? You know, we all
Well,
love the Hollywood movies, but what's the reality of all of this stuff?
okay, well, the one that we're looking at right now live, and by the way, as we stare at the exact correct spot, anybody who's looking at this live image through the Slooh telescopes, the giant Slooh telescopes, if you're not seeing anything moving or streaking, this only means that although we're looking at the right spot, you should be reassured at that. Don't go away saying, oh, well, we were looking, we didn't see anything. What you should be telling your friends is we looked at the exact right spot on a night of the full moon, and this
Yeah.
little object, 194 feet in diameter, was just a little bit too far away for us to see it streaking, and that's good news because it means it wasn't close enough to really scare us like the one that you're talking about. Okay, what size does it have to be? Well, that one
Yeah.
from February 15th injured 1,000 people, even though it blew up over 5 miles in the air.
Wow.
Imagine if it had been made of slightly sturdier stuff or had a different trajectory and happened not to be unstable enough to blow up, but was
Mm.
able to penetrate the atmosphere and explode at a lower atmosphere. If it injured 1,000 people, blowing up as high as it did, you can imagine what would happen. This is a much larger one than that one, the one that we're seeing tonight. This is
Yeah.
probably 4 times the size of the Siberian incoming object of February 15th.
Yeah.
So it's a good thing this is passing us by a safe distance.
Yeah, and of course, what keeps going through my mind, really, Bob, is how lucky we were, or how lucky the Russians were with that incident. Because if that thing had been coming down at a slightly different angle, that would have caused a huge amount of damage rather than burning up in the atmosphere. So.
Yep.
Bob, we're going to be rounding up the show fairly shortly. I just want to remind people the telescopes we've been using tonight to try and get these live views, really challenging conditions tonight, to try and image this very faint object. But we're using this as an example of these things are literally raining into the inner solar system. And in February, we had this big wake-up call that we should be doing something about it. 2 months later, NASA has their funding cut. their funding slashed in their efforts to try and locate the remainder of these objects, and we know there are thousands of them out there because we continue to discover them, virtually every
We'll
week.
keep watching here at Slooh, won't we?
We will. Well, Slooh members, there's a small group of them who have actually got together and have joined a kind of campaign, and they're searching for comets and asteroids. And as I said earlier, they are a small group of them are going to be watching another asteroid live later on tonight. And don't forget that if you are a Slooh member, you don't just get to see the images from your own missions when you control the telescope, but you see it from all of the other members as well. So really, if you're interested in space and astronomy, or your kids are, then please do consider supporting Slooh, our live public outreach work like this show and many others that we do on a weekly basis. If you enjoy those and think about supporting Slooh, join Slooh, or maybe use the iPad app. So, Bob, just to think about tonight's show, what are your final thoughts that you can give people on these near-Earth asteroids and the threats that they pose to us?
Well, let's keep watching here at Slooh. This has been quite an exciting year, and I look forward to the next one.
Absolutely, and I think that's probably a good note to end on. We do keep a very close eye on these things, and we're going to be bringing you the big ones, the fast ones, the exciting ones, the interesting ones. And don't forget, only last year, Slooh members, we were watching virtually live as an asteroid or comet plummeted into Jupiter's atmosphere. So, space, and our solar system especially, is an incredibly dynamic place. And these little objects coming in to our little neighborhood, our little corner of that space, are a little bit worrying. We do need to support NASA. We need to encourage our governments to do something about this, to track down and locate the last few thousand of these things. If we could ever do that, Bob, I think that's going to be too challenging to find them all. But anyway, thank you, Bob, very much for joining us tonight. If you
My
enjoy
pleasure.